All right. So let's refresh a few things. Let's refresh a few things. What is on your desk that you're?
Go look. What color is your shirt? It's actually gross. It's
Yeah, baby.
It's actually throw up on my desk.
Is that throw up on the wall or no?
I did know.
There's throw up on my desk.
This is a sketchy spot.
It was like grape juice he had been drinking this morning, and he just launched everything.
That's disgusting.
Yeah. All right. So let's kind of recap what we've been working on. So we are looking at last night's homework. I'm not going to combine mark it off yet. I'd like to just go over it, make sure you're good with it, and allow you to hang on to it so you can have it as a part of a study guide, right?
Yeah.
So you all ready?
Yeah.
Okay. So last night's homework, it talked about if a line's parallel, perpendicular, or neither. Correct?
Yeah.
So let's take a look at number 1. There was problem number 1, and feel free to copy down, make changes, correct anything you need to do.
So we're just saying the form and the top.
All right. So we have these 3 equations, our 3 points, threads of points. So remember we said yesterday that there's exactly one line that will go through any 2 points, correct? So there's exactly one line that goes through the blue, or the red, or the green. So you need to know the slope equation. The slope equation's this. Let me ask you all this though. If I didn't give you the slope equation, but I gave you this equation, do they kind of look the same? Yeah. So if I were, m is being multiplied times this whole quantity. So if I took this whole quantity here, and moved it underneath here, would it be about the same? What do you think? Hello?
Yeah.
Looks good.
About the same?
Yeah.
Good to go?
Yes.
Okay. All right, so I just wanted to give you that heads up. So let me just get rid of this because that's not part of the question. All right. So I'm going to use x1, y1 on each of these. x2, y2. All right, so let's find the slope of this first one. So I get 3 minus 1 is 2. 1 minus minus 1 is 2. So I get a slope on the blue of 1. Agree?
Mm-hmm.
And if you don't have anything out, you're more than welcome to get something out. Right. Just a hint. All right, so I know that the blue has a slope of 1. So then this one I'm going to do the same thing with. All right, so slope equation, 2 minus 4 is negative 2. 0 minus minus 3, or 0 minus 3 is this. So this I have a slope of 2 over 3. So 3 minus 1 on top, 1 minus, cool. I got a sneeze, it's coming. Come on back.
Bless you.
It's coming. Almost there.
Watermelon.
Bless you.
Bless you.
Woo! Watermelon. All right. Hey, can anyone tell me, what can you tell me about the blue versus the red points? Are they parallel? Are they parallel? Yes or no?
No.
No, why not?
Because they're not the
They're
same.
not slope.
The slope is different. Are the two slopes, are they perpendicular?
Yes.
Well.
Perpendicular means I have to flip over the fraction and change the sign. So I have to have positive and negative,
Oh, no.
and I have to have flip over. So are the red and the blue perpendicular?
No.
No. All right, so now let's figure out the green. So again, I'll find the slope. So 3 minus 1 is 2. 3 minus 0 is 0. So then I get this to be 2/3. What can you tell me about that? What can you tell me about that? Yeah.
B is the exact same to C.
So the green and the red are the exact same. So what can you justify?
They have the same slope.
Same slope, which means they are
Parallel.
parallel. Perfect. Any questions on problem number 1? Yeah.
I don't have a question on problem number 1, but I do have a really good idea.
Okay.
We should, for this class, we should do like Secret Santa, or like if someone's Jewish, like Hanukkah Harry or something.
What?
Hey.
Hanukkah Harry.
Is
that like
anyone
a crazy-
Jewish?
Is anyone Jewish?
No
No.
one's Jewish?
We're not talking.
Secret Santa.
Right, guys, we're not gonna. Great idea, listen.
Why did that come to your head?
I love
I
it.
was
You can bring me any
questions.
gifts you can bring me any gifts you want. But
You forget a present.
I was just
Did I?
thinking
Get you a
about
thing of
good
ice cream.
Christmas.
I always forget
I think it
presents.
was the voice.
I don't give gifts.
Okay.
You all get the gift of my time. All right, so moving on to number 2. Number 2. So then they gave us this equation. We have 2y equals x plus 12. So there's one equation. And then another one is 2y minus x equals 5. And then my last one is 2y plus x equals 4. Okay, so we are not able to determine what the slope is right now because we need our equations to look just like this. So you're going to have y all by itself. So that slope-intercept form, agreed? And whatever is attached to the x that we've solved for y is the slope. So on this first problem, how do I get 2y not to be 2 times y? What do I have to do to everything? Divide everything by 2. Okay, y equals x over 2 is 1/2 x plus 6. So what's the slope of the green? What's the slope of the green? 1/2. Everyone okay with that? Do what? Oh. All right. So on the red, I need to now figure out what to do. So I want to get y by itself. So if I add x to both sides, everyone okay with that? And how do I get 2y to become just y?
By 2.
Divide everything by 2. Okay, and so that gives me y equals 1 over 2x plus 5 over 2. What's the slope of the red?
1/2.
1/2. What can you tell me about the slope of the green and the slope of the red?
They're parallel.
They have parallel slopes because they're identical. Anyone got it? Like, dude, I don't understand that. You?
Yeah, I'm so confused.
On
Like just the entire thing.
so all I'm doing is getting y by itself. So this, I mean, this is on.
Oh, okay.
So this is what. So this is like work that we had done long ago. And we wanted to get x all by itself. This is called the two-step equation, Algebra 1, second week. Right? Negative.
Like I get that. I'm just
Okay, but that's all I'm doing with those. This is all I'm doing. So watch. So on this first one, this equation here, I want y by itself. So I want to get y all by itself. I want to get y all by itself. So how am I getting y by itself? On this first one, I already had y almost by itself. It was attached with a 2. Divide everything by 2. So x over 2 is 1/2.
Right.
And then 12, right?
Oh,
And so this and this, that's the slope. Whatever's attached to x is the slope. On this one, whatever's attached to x is the slope as well. Okay, being the slopes are the same, that means those two lines are parallel to each other. If you're graphing, they don't cross. So let's try the last one. I want to get y all by itself. So yeah, I'm going to subtract x. Everyone good there? Let's move this down a smidge. I get 2y is equal to negative x. And that's a positive 4. Everyone agree? All right, let's divide everything by 2. So I get y equals negative 1 over 2x plus 2. So what's the slope of this one? Negative 1/2. All right? So is negative 1/2 the same as positive 1/2? No? So one's positive, one's negative. They aren't perpendicular, even though one is even though one of them is a positive, one's a negative, the rule for perpendicular is it has to be switch signs and then the fraction flipped over. Okay, so we would need the blue to be -2. Yeah.
What's perpendicular?
Two lines that intersect across at 90 degrees. Okay. All right. So are we okay with number? So between the green, the red, and the blue, the green and the red are parallel because the slope is the same. The blue has a completely different slope, so there are two lines that intersect each other, but they don't intersect at parallel or perpendicular lines. Okay? All right, taking a look at number 3. And again, this is great review for y'all for the quiz that we have coming up. Okay, so we want this. We want to find the line that's parallel to this that also contains the point 1, 3. So is this problem set up to see the slope right now?
No. Yeah.
You got one of the answers, right? What is it?
Yeah.
Which is it?
Yeah.
Why is it yes? What is my slope then?
Gives you
Two.
negative 5, 2.
What's my slope?
2.
2x.
It's just 2. Whatever's attached to the x is the slope. If you solve for y, whatever's attached to the x is the slope. Okay?
Y minus 3 equals.
Do what? Oh. So, you will be given this equation. It'll be at the top of your test. And this is what we worked on yesterday.
Oh, I know that.
Okay, so this is called the point slope equation. You will be given this equation, and if it says, hey, find me the equation that's parallel to that, so I need to have the same slope because same slopes are parallel, right? And then I have to realize this is an x1, this is a y1. Okay, so you get y minus 3 equals 2 times x minus 1. I just found the equation that is parallel to the blue equation. I found the equation that also contains the point 1, 3. Okay? Yeah.
So for point slope, the y minus y1, will you make us solve the actual thing on the test?
I don't think I have it solving y equals mx plus b. I just said, if I say find the equation, find the equation. I think
So just find the equation, don't solve the equation.
yeah, just, that's the equation, done.
Don't go
Nothing
far.
more to do.
Okay.
Easy way.
Huh?
Don't take that one.
Yeah. All right, number 4. Number 4. Let's see if we can see the pattern here. We have this point given, and we have this equation given to us. All right, so we want, again, find the line that's parallel to that. So are we able to identify the slope?
Yes.
Yes, it's y equals. So what's the slope of this one?
-1.
-4. Okay, I want to find the equation that's parallel to this, but also contains that point. So again, on your test, on the very front, right by your name, this equation will be written, or will be already on there. Okay, so you're going to go y minus 1 equals -4 times x minus minus 2. X minus minus 2 is x plus 2. Right? Done.
Let's go.
That's it. So this equation right here is parallel to the red one. That equation right there also contains the point -2, 1.
Ew.
Okay? Any questions there? So then, as we move on to number 5 is very much like number 1, but they just want to know, can we determine if it's parallel or perpendicular? It looked like number 1, I think we had parallel situations take place. But let's take a look at number 5. So I have this point. I have this point. And I have this point. Everyone agree? So 3 different sets of points. How many points define one line? How many? 2. So each one of those defines exactly one line. So let's figure out the slope. And again, I'm not giving you the slope equation. You have to know this. Okay? But again, if I have given you this equation, right here, if I take this and I divide it and bring it over here, you have y over x. Y over x. It's the same thing. Okay? But you have to know this equation. You can generate it from this equation pretty easily. Okay? All right, so x1, y1, x2, y2. Okay, I'm going to find the slope. Ready? -1 minus 3, 1 minus minus 2. -1 minus 3 is -4 over 3. So the slope of the purple is this. So if I find another one that has that exact same slope, that means they're parallel lines. If I find a slope that is positive 3 over 4, positive 3 over 4 is a reciprocal of negative 4 over 3. It's also opposite sign. Agree? So let's do the same thing with this. x1, y1, x2, y2. So I'm going to go 4 minus 1 is 3. 1 minus 3 is -2. So is the purple and the blue, are they parallel? Or are they perpendicular? Or are they neither? Are the slopes the same? Are they flip over opposite signs from each other? Or are they just different slopes? Different slopes. So these two lines will cross, but they don't cross at the special right angle, 90 degrees. All right, last point, x1, y1, x2, y2. So -2 minus 2 is -4. 3 minus 0 is 3. So I get -4 over 3. What can you tell me between any of them? Are any of the slopes the same? Give me colors.
Purple and red.
Purple and red, what about them?
Parallel.
They are parallel because they're the exact same slope. Okay? So the blue is just another obscure slope. There's nothing there. Yeah.
Wait, so could A and C be perpendicular to line B because of the opposite reciprocal? Or
Wait. Which one, the purple and the red? Did I write the wrong ones down?
no, could the purple and the red be perpendicular to the blue?
No, because that's 3 over -2. So all three of the slopes are all negative. Perpendicular slopes, one's positive, one's negative. And then they're flip over fractions, exact flip over fractions. So if you had 4 over 5, the perpendicular to 4 over 5 is -5 over 4. If you had -1/3, the perpendicular to that is positive 3 over 1, which is just 3. Okay. All right, 9, I think we've done these to death. 7, 8, or 6, 7, 8. Let's look at 7. So problem number 7, I have this point given, and I have this equation. So let's identify what the slope of this equation is right now. What's the slope of that equation?
1/3.
1/3. Everyone feel comfortable with that? Yes. All right, so I want to find the perpendicular slope. So, being original slope's positive, what does this slope have to be? Negative, and negative what?
3.
-3. There it is. Okay, so now I want to use this point and this perpendicular slope to find the line that's perpendicular to that also contains this point. I got x1, I got y1. I get y minus -3, which is y plus 3. Agree? I'm using the perpendicular. I have x minus 2. So this equation right here is perpendicular to our original. Means they will cross. It will cross and it will be a 90-degree angle. And it also contains the point 2, -3. Yeah.
So I put down y equals -3x plus 3. Would that be okay?
Yeah, you solve for y. Yeah, you just did extra work, but you're going to get the same answer. Absolutely. All right. So, if you feel comfortable with that, that's fine. I want to take kind of a real-life adventure with this math and how it's going to be applied. Is that okay? You can sit and watch. You can sit and take notes. Just figure this out. And we're going to try the best we can for a real-life situation, would we really go through life and say, hey, we're going to do this math, doing this? No, I'm just trying to give you a representation of some math. Is that okay? So, have you ever seen a water tower? You know, it kind of looks like that. They're tall. So down on I-25 and County Line, roughly, there's a huge water tower. And do you all know what the job of a water tower is, other than to store water? Yeah.
Well, it stores water and then does it like
Those things.
It does what?
It doesn't like send out and it provides water.
So this is actually what this does. So this is a large tank, and there's a lot of water that's in it. And so what they do is this. You have water that is being pumped up here, and then you have water that then flows out of here. What they use a water tower for is to allow you to have consistent water pressure in your water lines. Okay? Meaning, you don't want to turn your water on real fast, and then it goes... Like if any of you have a well, which some might, I don't know. But if you have a well and your well is starting to go dry, what normally happens is your well fills up with a certain amount of water. And if you use too much of it, your water gets less and less and less coming out of the faucet. It gets slower and slower and slower down to a drip. Okay? That just means that the water table right now is low as far as your well goes. But what this water tank does is it allows water to flow in and then allows water to flow out. This allows your water to be a consistent pressure when anyone downstream of it. I mean, you have a lot of faucets between here and that water tower that's down that way. Other things that they do rather than have an actual tower, you know, if you've driven down into Highlands Ranch, you've taken Highlands Ranch Parkway south of C470. You have those large homes there on the east side of the road. As you get up to the retirement community home that's right before Highlands Ranch Parkway, there's a huge water tank up on the hill. Well, what is that? It's serving the exact same purpose. We'll put a water tank up on a hill rather than build a tower itself. It's serving the exact same purpose. So we have water that's being pumped up here, sitting in this large tank. This large tank is putting a consistent amount of pressure on the water that's leaving it, and that's allowing your water pressure to stay the same. That's the whole thing. So I want to talk about a water tank in a theory that we could do. So let's say we have a water tank, and you have someone down here who turns this water supply off. So the tank will be full, and eventually it'll drain all out. Does that make sense? Are you with me on this scenario?
Yes.
Okay? And I'm just going to make up some figures, but this is all related to the math that they're working with. Let's say we didn't realize the water had been cut off, but we had sensors that sent us information. So let's say at 3 o'clock, you went over to your computer and it said that you had 5,000 gallons of water. Okay? Do you think that's unrealistic?
No.
I mean, 5,000 gallons, honestly, I could fill up this room and this would be about 5,000 gallons of water. So could you visualize what 5,000 gallons of water would look like?
Yeah.
All right, go turn on the hose outside. We'll fill it up in there. So does that make sense? So there's some person who's probably their job is to regulate the water towers to know if we're using too much water. And if we're using too much water, what they will do is they will tell the pumps further down to pump more water up to this to keep the pressure up. But, you know, let's say somebody down there, you know, decides to turn off a valve. You got a bunch of high school kids who are like, hey, what does this do? You know, turn the valve off. Could happen, right? I don't know. Maybe they have better. But then, let's say at 6 p.m., they go to see a report and they see that there's 2,000 gallons in the water tank. So does everyone feel comfortable to say that there is less water in the tank later in the day? Is anyone like, don't get it? Okay, still with me? All right, so we want to turn this into a mathematical problem. Okay, so let's figure out the slope. So I'm going to take 3 comma 5,000. That's 1 point. So my x value is representing the time during the day. And then 6 p.m. is 6, yeah. And at 2,000. Everyone seem comfortable with that?
Yes.
So as the day is progressing on, something's going on with this water tank because it has a lot less water in it. Agree? Okay. First thing I want to do is I just want to find the slope. Again, I want you to know this equation. It's not a hard thing to remember. And then I'm going to come to my points, and I have to label my points either x1, y1 this way, or maybe label this one x1, y1. But because I've already labeled that, I'm going to go this way. All right, so I'm going to go 2,000 minus 5,000. 2,000 minus 5,000. Is it negative 3,000? Is that okay? And then 2,000 minus 5,000, and 6 minus 3 is? Can I reduce that? What does it reduce to? Negative 1,000. Okay, so let's think about this. In the context of our problem, we have time and we have gallons. Agree? So what do you think the slope means in the context of this problem? Just give me a shout out. What do you think? What do you think? What? Lost? Okay. It lost? Lost what?
1,000 gallons.
Per minute?
Almost. This is 3 p.m., 6 p.m.
Oh, every 3 hours.
Per hour.
Whoa, what?
Per hour.
Per hour. Yeah, my denominator is 1, right? So I'm losing 1,000 gallons for every 1 hour the day progresses on. Is that okay? Now, I don't know if this would be a huge problem. People would be calling, going, hey, Mac, you got a problem on tank 3. But this could be something that we could easily work on. Okay? So a water tower, someone turned off the valve. I don't know who. The tank had a reading at 3 o'clock that had 5,000 gallons in it, which is what it should have, maybe should have, I don't know. And then at 6 p.m., there was 2,000 gallons in it. Okay? We found that we have a slope that is negative 1,000. So in the context of this problem, we get rid of 1,000 gallons every hour. That's how I talk about the slope in the context of the problem. What do you think about that? The slope in the context of the problem. Is there anything that I've done right there you're like, this is impossible? I think it might be straightforward, but I'm the teacher, so that kind of sucks being the teacher and that I get it. Hey, it's 1, 2, 3. I saw that. Okay? All right, now, the next thing I want to do off of this is I want to create myself a linear equation in the context of this problem. Okay? I have the slope already, and I'm going to pick one of my points. So I'll just pick that point. I had to pick one of them. Doesn't matter which one. I'll just pick that one. So I'm going to use 3 comma 5,000. That's 1 point. And the 3 represented 3 p.m. and the 5,000 represented 5,000 gallons. And then I have a slope of negative 1,000. Is that okay? So that's our information. We were able to develop that information from our problem. So now I want to figure out my equation. So I'm going to go y minus y1 equals m times x minus x1. Now if I just want to find the equation, I could probably stop with this equation. Things that I have to know is that's an x1 and that's a y1. Agree? So then I'm going to go y minus 5,000 equals my negative 1,000, right? And then x minus 3. Okay? Now, normally I'd say, dude, you're done. You're done. But sometimes when we deal with these kind of problems, it's better to solve for y equals, okay? Because there's information we can get from y equals mx plus b. So sometimes it might be a good idea to make this look like this equation here. Okay? Does that equation there have any parentheses? No. Does it have anything with the y value? It's just y equals, right? So looks like we'd have to move the 5,000 over, and let's get rid of the parentheses. So I'm going to get rid of parentheses. I'm going to distribute here and here. Still with me? Okay, y minus 5,000 equals negative 1,000 x plus 3,000. Does everyone feel comfortable with the math we have? Okay. How do I get the y all by itself? Add 5,000 to both sides. Okay. So that's gone. So I get y equals negative 1,000 x plus 8,000. Okay? This tells me a lot. Okay? What's my y-intercept of this equation right here? Yeah, so it's 0, 8,000. Okay? So let's figure out, so this is another point. So let's figure out what the heck this even means. Okay, so hang on. We said that at 6 p.m., oh wait, go up a little bit higher. We said at 3 p.m. we had 5,000. At 6 p.m. we had 2,000. Okay, and we created 3, 5,000, 6, 2,000. And this means 3 o'clock, this means 6 o'clock, right? So let's see if we can decipher what the heck, what does 0, 8,000 mean as far as time? So 3, 2 o'clock, 1 o'clock,
12.
noon, right? What about noon? At noon, so that's 12 p.m., right? Right? Because 12 midnight is 12 a.m. We had how much? How much water? How much?
8,000.
8,000. So what does the y-intercept refer to in the context of this problem? It just refers to, hey, when we started the afternoon, we had 8,000 gallons. When we started our scenario, we had 8,000 gallons. The complete capacity of our thing held 8,000 gallons. Okay? So at noon, we had 8,000 gallons. Now here's a question. When will we have 0 gallons? Okay, we can do it a number of ways. We're losing 1,000 gallons every hour, right? So at 6 p.m. we had this. So what would we have at 7 p.m.? 1,000. What would we have at 8 p.m.? Nothing. So at 8 o'clock on this night, this water tank's empty. Okay? But that is a real life look at this information. Okay? What time are we at here? 48?
Yep.
Should we do one more? So this is a decreasing slope. Agreed? Okay. Now, let's change it a little tiny bit. Let's talk about a bathtub. This is one of them fancy looking bathtubs. I don't know. I can't draw real well. We got water in our bathtub. Right up here we got some sort of faucet that allows water to go into it. You with me? Now, I don't know if y'all grew up in a house like mine. You know, in Arizona, I swear, we had like a bathtub and like no one ever used it. Is that kind of like your home too? Like it might be the place where you stand in it and go in the shower and then you might put the stupid sliding doors on and you get out and you kick your foot on the stupid railing. You guys know what I'm talking about?
Yeah.
Yeah.
All right. So, but what you might have noticed in this bathtub is, oh, I have a drain. So you pull your drain up, you have your water running, and then you turn your water off. And a lot of times, what do you hear? What do you hear with your drain? Yeah, it's starting to leak a little bit, right? the water's going down a little bit because you didn't really create a really good seal. The drain on the thing to plug up the drain on a tub where you pull up and lower down the little mechanism where you plug it up, they're not a great seal. It's not supposed to be the best thing on earth. So it's going to leak a little bit. So let's just say we decided we have a 70-gallon bathtub. So we fill it up. We fill up the bathtub. We're about ready to soak. We had a good, long, hard workout. We want to soak in a nice, warm bath because you don't have the hot tub at the house. You with me still on this adventure? And let's just say we had 70 gallons. Well, you're about ready to get in, and you realize, dude, I don't have my cell phone. Right? Well, because you might need to check your status and stuff and your music and all that, right? So this could happen. You got your tub full. It's all full. You turn the water off. It's full. It's got 70 gallons of water in it. You're like, yeah. And let's say you have marks on the tub that tell you there's 70 gallons. I know you don't, but let's just pretend. So you run downstairs. You grab your cell phone, and you realize, oh shoot, I need to tweet or text or face planter or snap goop or whatever the thing is on the phone. You get busy. Something happened on the phone. You're looking at it. You got to stay up to par with everybody else. You have to like and swipe and trash and all those. You still with me? I know my verbiage is horrible, but just stay with me. But let's say that you are gone for 15 minutes. I don't know what time you filled the tub up, but you were gone for 15 minutes. So you come back after 15 minutes, and there's now 55 gallons in your tub. Okay? So does everyone agree that the drain's draining? It's not really sealed? And again, I'm just trying to create a scenario that we could maybe understand. All right, so let's create 2 points off of this information. So at 15 minutes, I have 55 gallons. Meaning, like, I walked away. I was gone for 15 minutes. A certain amount of time took place, and I have less gallons in my tub now. So let's figure out this one. At 70 gallons, water was on. You turned it off. The instant you turned it off, there's 70 gallons in it. You still with me? So how would I represent that time right there? Zero. Yeah. So I turn the tub off. It's at 0. Oh, dude. Go get my phone. I'm gone for 15 minutes because I got to check out all the good stuff on the internet and what's going on snapping and chatting and booking. I don't know what it is. So let's try and figure this out. Let's create a slope. So I'm going to go x1, y1, x2, y2. You still with me? And I know my slope equation is this, and I've asked you to know this. All right, so then we got, let's see, 70 subtract 55. Yes? Okay. And then 70 subtract 55, and then 0 subtract 15. So 70 subtract 55, help me out. I don't know. Is that 15? 15 over negative 15? 15 over negative 15 is negative 1. What does the slope mean in the context of this problem? I got a negative 1 slope. What does that mean?
Negative 1 gallon per minute.
Yeah! 1 gallon has leaked out down the drain. Oh, I know. Yeah, maybe you forgot to put the plug in. I don't know. But, so you're losing 1 gallon of water every 1 minute you're gone. Okay, so this is a real life depiction of this event. Okay? You might see this type of stuff on the quiz for tomorrow. So I think for tomorrow,
Are we turning to page 101?
why don't we just call that? Why don't we call, if you were here, I'll put 4 in for you. How's that sound?
Yeah.
All right. So I think what I'd like you to work on for tomorrow, and we'll have time to go over it, is on page 104. Page 104. I would like for you to do a good try of number 12. That's all I want you to do. I just want you to try that one. And then I got to see if there was another one that's similar to that. Oh, and then on page 107, I want you to also try number 18. So we have 2 problems to try. We will spend 15 minutes going over those tomorrow, and then we have our quiz. Great if you try those, all right?
It's not on your desk.